Assalamu alaikum. I am Muhammad Jamshid here from MTS Section A. Today we are going to review our ECA electric circuit analysis, in which we have learned about the basic elements and different type of circuits. These circuits consist of resistors, capacitors, and inductors. The main basic thing that run these circuits are voltage sources and current sources. Basically, the voltage source that we have in our homes and such, this all of the sources are voltage sources, which maintains a potential between two nodes, which help the electrons to move from higher potential to lower potential, which we can actually say that the current is flowing. So the voltage source maintains a potential difference, and current source is a two-terminal circuit element that maintains the current through its terminals. It makes the current flow from one end to the other end of any branch or any circuit. Resistors. Resistors is basically a component that stops the flow of electrons. It means that resists the current to flow through it. It gives a potential drop across it, which decreases the amount of current flowing through it. A resistor a resistor is a two-terminal circuit element that has a constant ratio of the voltage across its terminals to the current through its terminals. The value of the ratio of the voltage to current is the defining characteristic of the resistor. As I have told you before, that it gives a voltage drop across it. So we can say that it decreases the voltage, so it decreases the current flowing through it. Inductors. Inductor is a coil of wire through which electrons move and energy is stored in the resulting magnetic field. In the inductors, basically, it we can say that when it is removed from any source, it supplies the current of which amount decreases with the time. It stores energy in the form of magnetic field, and then it supplies that energy to the circuit, which decreases with the time. And the phenomena in the inductor is inductance, and inductance is measured in henries. Capacitor consists of two plates, two parallel plates, which stores the charge between them, and it stores energy between it, and it also supplies the energy when the source is removed to the circuit. And with the time, the energy supplied by it decreases. Then we have Ohm's law. It is a direct relation between. It shows a direct relation between voltage and current, where the resistance is kept constant. We can relate the equation by V equals to IR, where V is voltage and I is current, and R is the resistance of the capacitor, the resistance of a resistor. And if we make resistance of a resistor constant, then by increasing voltage, we can. It shows that by when we increase voltage, the value of the current also increases, and vice versa. When we decrease the voltage, the value of current also decreases. Then we have Kirchhoff's current law. Kirchhoff's current law shows that here I want to tell you about two things: a node and a loop. Node is a point where two elements connect with each other. It means that that is a piece of branch between the two circuit elements. The circuit elements could be any source, capacitor, inductor, or resistor. It could be anything. The node is a point where node could be a branch or a piece of branch where uh, at which the ends of two different circuit elements are connected. They could be same. I actually mean that there should be two circuit elements. Kirchhoff current law says that at any node where sorry, I want to repeat that it is not necessary that there should be only two components, three components, four, or more than that. Components may join to a branch at a single point. As a circuit you can see on the screen, we can call Kirchhoff's current law in short KCL. KCL states that the sum of the current entering a node will be equal to the sum of the current leaving the node. It means that at any node, the current entering to the node must be equal to the sum of the currents leaving to the node. As you can see, on the screen, that a current coming from the 12 volt source is 9 amperes, and it divides again into 3 points. But the node is common. These two dotted points in front of this 9 milliamperes emitter, and the next, these all are common node. They are, this is a single node, and three branches are connected to it. You can see that 4 ampere is passing through 3 kilo ohms of resistance. 3 milliamps is passing through 4 kilo ohms of resistance, and 2 milliamps is passing through 6 kilo ohms resistors. If we sum up them all, 4 plus 3 plus 2, it gives us 9, which is proves that KCL is true, that the current entering to the node is equal to the sum of the currents leaving from the node. And the next is KVL. uh, Before I told you about a loop. A closed loop is which, as you can see here, the closed in the lower diagram, that from one end to another end, this is closed thing, that if you make a circle or such kind of anything which is closed from I mean that its two ends gets connect to each other. If between that there could be any circuit elements and anything. KVL says that KVL says that the voltage drop and voltage rise in a closed loop, the sum of them all must be equal to zero. When we read definition, KVL is a result of the electrostatic field between conservative, which states that the total voltage around a closed loop must be zero. It means that in any closed loop, the voltage rise and the voltage drop, as if we take any circuit which only has the simplest circuit which has source and three resistors. The voltage source is giving up us a voltage rise. It means that 12 volts is coming from the source, and 3 volts is dropped across 3 kilo ohm resistor, 4 volts is dropped across 4 kilo ohm resistor, and similarly 5 volts are dropped across 5 kilo ohm resistors. If we sum up them all, these voltage drops, it comes equal to the voltage rise of this closed loop. We can use these theorems or these laws to solve different circuits to find any unknown voltage if we know all of the voltage from the other circuit elements in that loop. Then we have Thevenin theorems, in which we have different steps. Thevenin's theorem is basically a technique to solve any circuit, or to or we can also do it for maximum power output. Maximum power output is when the by using Thevenin theorems we can find R Thevenins. I will tell you later about R Thevenins. But for the maximum power, we can find the value of the resistance for which the source and the internal resistance of the circuit gives maximum voltage and maximum current flows through it. In Thevenin's theorems, through the use of Thevenin's theorem, we have the ability to reduce a complex circuit down to a simple series circuit. By Thevenin's theorems, we can compress all of a bigger circuit into only three components: a voltage source, we all can also call it VOC or V Thevenins, R Thevenins, yeah, or we can, which is also called Thevenin resistance, and then we have the load. These three components come in the series. uh, we can always find the value of the third one if we have the value of 2. Mostly we have to find the value of R Thevenins or R load in these circuits, so which the other two are given. Its process includes that remove the load, determine the voltage seen by the load, means we can remove the load, and by using any technique like nodal analysis, mesh analysis, we can find that. And then we have to find R Thevenins by doing the voltage sources short and by doing the current sources open. In this way we can find R Thevenins, and then we can we can conclude these all things in a single circuit, which consists of one voltage source, one Thevenin's, and one load. These are the process. These all are the steps in which we have to remove the load, then find the VOC or the V Thevenin's, and then R Thevenin's, and this is an example solved for that. You can go through it. Then we have Norton theorems. Norton theorems is basically a same thing, but it concludes or compresses all of the circuit in three elements, that are one current source and two resistors, where one resistor is R Thevenin and the second resistor is R load. But the difference is here these resistors should be in parallel with the source or with each other. In the above, we have in the above slide, we have seen that in Thevenin's equivalent, or the Thevenin's theorem, we make two resistors and one voltage source in series, and here we make one current source with two resistors in parallel. Now we have the same process for that. All just we have to in the above Thevenin's theorem, we find voltage across that load VOC, and here we have to find the current through that load, which we can also call ISC. VOC stands for voltage of the open circuit, as we remove the load and find the voltage there by using mesh or nodal analysis or any other technique. It is up to you. And here we have to just short the load, and we have to find the current through that branch, current flowing through that branch. Here, and then you can see equivalent Norton circuit, which was a single current source, two resistors. Then we can do different techniques like current divider, and V equals to IR using Ohm's law. We can find the voltages and currents of R Thevenin and R Norton. I have told you before that we can use these theorems to find, especially Thevenin's theorem. We can use both theorems, as the way of finding R Thevenin for both theorems is same. Uh, in any circuit, a source delivers its maximum power when the value of the load resistor is equal to the internal resistance of that source. Internal resistance of that source, we can also call it the all of the resistors which load resistor C or suffers from the whole circuit. We can find its equivalent in a single resistor, that this is all of the resistance that is given to that R load or resistance load. If we take R load, a resistance of the load equal to that equivalent resistance, which all of the circuit is delivering to it, we can have a maximum power. It means that the voltage and the current both, if we use the formula P equals to V multiplied by I, or we can use other formulas, P equal to I square R or V square divided by R, we get the maximum power output there. And let's have a review that we have learned about different sources, voltage sources and current sources, then circuit elements as in resistors, capacitors, inductors, and then this Ohm's law. Ohm's law is a formula which we can solve any circuit using this formula, V equals to IR, that if we know voltage across voltage across a resistor and its resistance, we can find a current, and vice versa. If we have current and resistance of the resistance of that resistor, we can find voltage across it. And similarly, if we have voltage through any component, through a resistor, and voltage across a component and current through a resistor, we can find the resistance of that resistor. Then KCL, that the sum of the currents entering and leaving the node must be equal, or their sum should be zero, that you have to take entering as positive and leaving as negative in this form, or you can say that the current entering the node is equal, the sum of the currents entering the node should be equal to the sum of the currents leaving the node. And then KVL, that sum of the voltage rises and voltage drops must be equal to zero in any closed loop. Here the word I am using, closed. This is the restriction that the loop should be closed. It only applies on a closed loop. KVL only applies on a closed loop, that the voltage rises and the drops across the components should be zero. So it's sum of all of the voltages. And then I've told you about Thevenin theorems and Norton theorems. These are some of the examples that you can go through them. Here we have found VOC and then VOC or VThevenin and then R Thevenins. And then we have made a equivalent circuit consisting of one voltage source with two resistors in series. One is R Thevenin, one is R load. And then Norton theorems, in which we have compressed a large circuit into only three components: one current source and two resistors in parallel. One R Thevenin and one is R load. So this is our today's lecture. Thank you so much. You can drop your questions or any other thing that you want to discuss in the comment section. Thank you so much. Allah Hafiz.